So how does this slot in? Well, same exact idea will start things off. We can have one of the double bonds attack the hydrogen, which then pushes the electrons onto the chlorine. The result of this attack is to form a carbocation at the secondary position. But of course, this carbocation is stabilized by resonance. So I have a secondary carbocation stabilized by resonance with the primary carbocation that's stabilized by resonance. So secondary stabilized by resonance with the primary. The resonance hybrid, of course, has some double bond character on both and a partial plus on the internal position and a partial plus on the terminal position. So the chloride can then add potentially to either position. If the chloride adds to the primary, it will lead to the more stable, because of the internal double bond, product, but there's more delta plus at the secondary because it can better tolerate having delta plus at the secondary. So this is likely to be the kinetic product, even though it ends up being less stable. This, of course, ends up being a kinetics versus thermodynamics situation. So if the chloride adds to the greater area of delta plus, that probably happens relatively fast. That will lead to the kinetic product in a racemic fashion. Whereas if the chloride adds to the primary, that's leading to the more thermodynamic product, and this will be a single isomer. I'm drawing a reaction coordinate diagram for the process. The attack of the diene on the HCl leads to a carbocation intermediate, which is this one, stabilized by resonance. And at this point, our paths diverge. If the chloride attacks the more stable secondary carbocation, that will lead to a relatively low hump that it needs to get over, but it will lead to a relatively high final energy because of the terminal mono-substituted double bond. Meanwhile, attack of the chloride on the less stable of the two positions is likely to be a higher energy hump to get over that leads eventually to a lower energy product, as shown. The point of this reaction coordinate diagram, once again, is that the energy difference between the two products determines which is the thermodynamic product. The lower energy product is the thermodynamic one, whereas the product that's kinetic is determined by looking at the height of the two humps. The lower hump is the kinetic product, the one that happens faster, even if it leads eventually to a higher energy product.